So, very good afternoon, fellow Foundrymen. It gives me immense pleasure in interacting with you all for the 18th technical webinar for the year 2022-23, conducted by the Institute of Indian Foundrymen, Chennai chapter, online through Microsoft Teams. This program is being jointly conducted with the Southern Region of IIF. Now, to get things started, we now request Mr. S. Muthukumar, Chairman, Southern Region, to welcome the gathering.
Thank you, Vignesh. Hope I am audible.
Yes, sir, you're audible.
Yes, sir.
Yeah. Good afternoon to all. I have a great pleasure in welcoming you all for this webinar on behalf of Southern Region and Chennai chapter. We are conducting this webinar every week on foundry related topics. I hope the foundryman will take a lot of benefits from the webinar conducted by Chennai chapter and SR. Today's topic is on advanced refractories and flow control systems by Mr. Vivk Pol, Mrs. Foseco India Limited. We hope that this webinar will be a great knowledge sharing to all. Once again, I welcome you all. Now I request Mr. Vignesh Ramanan, Honorary Secretary Chennai Chapter, to introduce the speaker to the audience.
Thank you, Chairman.
Thank
To now introduce our speaker for the day, Mr. Vivk Pol. He's a qualified BE metallurgical engineer from the year 2005. He has total of 17 years of work experience, out of which 4.5 years is from an iron foundry. He has held various positions at Foseco India Limited, joined as an application engineer at Foseco India, worked in Initech project, Foseco patented process for ductile iron production, solutions manager, ferrous metal treatment, dealing with products like inoculants, ferrosilicon magnesium alloy, furnace and ladle scavenging fluxes for iron and steel, slag coagulants for iron and steel, etc. Solutions manager, foundry melt shop, dealing with advanced refractory products for iron, steel, flow control products for iron and steel, and products in ferrous metal treatment. He is currently the solutions manager at Foundry Melt Shop at Foseco India. So requesting Mr. Vivk Pol to take over, please.
Yeah. Am I audible?
Yeah, you're audible, sir. Sir, Jairaj, sir, requesting you to please switch off the camera, sir. Yeah. Mr. Vivek, you can start, sir.
Yeah. First of all, thank you very much for a very good introduction. And also thank you for giving me this opportunity to present my views on this esteemed platform. So it has been very great experience and honor to be associated with IIF, Chennai chapter and Southern region. So uh, again, thanks again. I will share my screen.
Yes, sir.
Yeah, so before I start the presentation, I would like to introduce one of my team member, Mr. Dhananjay Nene, who has recently joined Foseco in Advanced Refractory and Flow Control team. So during our question and answer session, we both will be here to answer the questions. And just Dhananjay, are you there? You can introduce.
Yeah, good afternoon, everybody.
Good afternoon, sir.
Yeah, good afternoon.
So I will start the presentation.
You got it. Okay. Thank you.
So broadly, the presentation is like the main three aspects: introduction about Foseco, its parent organization, Vesuves. Then we'll talk about refractory, and then various products, its applications, about ferrous foundries. So, like many of you, I'm sure, would be knowing about Vesuves and Foseco collaboration. Vesuves is Foseco's parent organization. Vesuves, which is mainly in refractory industries, like they are highly respected global leader in refractory solutions, and their main presence is in steel plants, cement industry, glass industries. And Foseco, as you know, we are in foundry chemical industries. So now the Foseco is a part of VCVS with the international presence of Foseco and VCVS. VCVS, we have like 65 manufacturing sites, like wide presence, wide network. That is what the meaning of this slide. Like wide R&D centers, like 16 R&D centers globally for VCVS. Foseco do have R&D sites and very wide global presence. As far as manufacturing sites for India is concerned, VCVS, Foseco put together, there are 5 locations at the moment, like Mehsana, Pune, Pondi, mainly foundry consumables, and Vizag for refractory materials, and Kolkata for like flow control systems, mainly like with respect to foundry, stoppers and nozzles. These are the main product lines. Apart from that, the flow control products which are required in steel industry, that are different. So overall, advanced refractory manufacturing facility is in Vizag, and flow control is in Kolkata. About Foseco, like a part of Vesuvius PLC, which is 100% dedicated for foundry industry. And Foseco always work to improve foundry performances by offering different product, technologies, services, and uh, like we do have local expertise peoples, as well as there is always a global team, Foseco global team, which is present for extending their support. So it is global exchange. Some foundries which have transnational accounts, so that common practice is also being shared, and this type of benefits we get and we can deliver to our foundry months. So about application engineering, apart from the advanced product technology, we do have softwares, in case of feeding system solution, we have simulated softwares. In terms of in case of metal treatment, we have advanced thermal analysis tools. So these are the backups, like advanced tools and product technology. With the help of this overall application engineering, uh, 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 is helping foundries to resolve the issues and to improve the performance. So just would like to touch upon the business model. So it is Foseco's base is customer centric. So customer focused. The understanding customer need is the first thing, and then how it goes, like in product offerings, innovation of products, to just to create value, and basically to uh, get win-win situation, uh, whatever needs are there that are being fulfilled with the help of world-class processes and technologies, and overall experienced peoples. So this is how we work. There are end to end, in product portfolio, if you look at, like from foundry process point of view, from starting to end, we have all the product. And the reason for displaying this slide is, now means we are talking about refractory solutions, and then how other product line can help. So that is some connection is there, means sometimes the problem is also somewhere in the metal treatment side, and we are focusing only on refractory side. So that's why uh, like uh, if we have complete picture, complete understanding, what is the defect, what are the various reasons, what are the various possibilities. So that's why the presence in all the um, sections, I would say, is required. So now we'll start with our presentation with refractory, means understanding about refractory. So what does refractory means? So for some or many of you, it is very basic, and you must be knowing all this. But still, we will cover quickly. The refractory is something. The material is something which can retain the strength at high temperatures, so the deformation will not be there. Then basically these are the materials which used for lining the furnaces, ladles, and out of total refractory produce, around 70% is used in iron and steel industry, like foundries, non-foundries, steel plants and all. So huge consumable, which is like getting consumed in iron and steel industry. About classification of refractories based on chemical composition and based on forms. There are like two ways we can classify. Based on chemical composition, any refractory uh, we can have three types: acidic refractory, basic, and neutral. And based on the forms, predominantly two, like shaped refractory and unshaped. So in shaped refractory, like bricks, well blocks, no, which for steel pouring ladles, well blocks are like these are basically precast. And unshaped refractories, these are called monolithics, and no, all lining materials for furnace lining, ladle lining, these are called as monolithics. Further, with respect to acidic refractory, basic refractory, and neutral refractory, the basic differences like acidic refractory silica base, basic refractory mainly magnesia base, and neutral is combination of magnesia and alumina. Normally, it is called as spinel forming material, MgAl2O4. So we'll see differences also, like what is the difference between acidic, basic, and neutral. Then as far as acidic lining is concerned, which is silica ramming mass, they have very good thermal shock properties. And if you consider basic, which is magnesia, which is having good slag attack, as good resistance for slag attack as far as steel metal is concerned. So the choice of refractory, normally it is made based on the what type of slag is getting generated in the furnace. For example, if it is acidic, means if it is iron, then the slag nature is acidic, and that's why acidic refractory, which is silica ramming mass, is used. And for steel, since slag nature is basic, then basic refractory is being used, the basic ramming mass. But like there are challenges with basic ramming mass, like thermal shock is not that good as silica ramming mass. Means I'm talking about steel melting practice. So then if acidic ramming mass is used, then it will not withstand. It will means it will withstand the slag attack. That's why the need for different lining material which can resist the slag, as well as which will have good thermal shock property. So that material is named as neutral ramming mass, which is neutral in nature, and mainly it is like combination of magnesia and alumina. So that combination is a spinel, and which works really good in terms of slag reaction and thermal shocks. So if we form like these shapes from shape type of shape, then like this is bricks are shape refractory, and you can see in pictures different types of bricks like high alumina bricks, magnesia bricks, well blocks. uh, like unshaped refractories, all monolithics, castables, plastic refractory materials, dry vibratable, which is ramming masses. These are mainly used in foundries. All other like these are products for steel, maybe for blast furnace, and means other than foundries, they can use. So some basics about various types. Dry vibe, like it is dry vibratable material. Mainly, like it is used for induction furnaces lining, whether it is steel or iron, and like we discussed, based on the metal type, or we can decide which with which lining type we should go. Castables are, it is the means the material which is widely used in the foundries for various applications, for ladle transfer ladders lining, pouring ladders lining, for maybe for furnace spout repairs linings. So highly consumed items in castable. So in castable there are again four types, no, based on the alumina, they based on their cement content, calcium oxide content. So which is a binder basically in castables, high alumina cement. So based on cement content, there are further four types. For example, conventional castables, which is having high high cement, high calcium oxide, and there is a correlation, like with higher content of calcium oxide, we need higher amount of water addition, so that the bond will form uh, as per our requirement. So uh, the content of calcium oxide reduces, then the water content also reduces, and then it goes into different types, like conventional castables having high calcium oxide, then low cement castables, then after that it will come like ultra low, and lastly no cement. These are basically four types, each types having their own advantages based on the application, of course, like uh, and selection of the customers also based on, like what is like ladle size, their temperature requirement, performance requirement, and finally cost also. When it comes to plastic refractories, they are basically phosphate bonded and ready to use materials. They are having very good workability. So by ramming application, we need to use it. So some details we will see in next slides. So again, this green uh, products are basically for foundry applications. Patching material, patching for say furnace lining, patching for ladle lining. So these are also some plastic materials are there, which can use very conveniently for patching applications. So basically refractory materials, like if you see the data sheet, so data sheet is not a specification. It's only confirm that type of product castable, which type of castable it is, like and then their physical and chemical properties, uh, the their chemical composition, typically alumina content, and in physical properties like what is the density and all. So um, uh, like for refractory, for means if you want refractory to deliver good performance, then some actions we need to take in terms of, like, from storage point of view, we need to ensure it is stored correctly, like it is away from extreme temperatures, and it should be always covered like this. And then the another point is installation practice, like uh, it is very important. If like very good refractory material, if you install it wrongly, then it will not give results. So it is always, we always say, like a standard refractory correctly installed will always be better than a good quality refractory badly installed. So installation practice, the way of installation is very important from performance point of view. With this, Foseco have wide range of products from various areas, and as far as about this presentation, like refractories and flow control, then some of the materials we have listed here. Of course, there are other products also. Now we'll we'll start some details of which products are used in foundry applications, the challenges with existing practices, and how we can overcome these challenges with the help of selection of good products, and by following the standard process for installation. So typically, as far as steel foundry is concerned, this is a layout as far as from melting point of view. So induction furnace, and sometimes it is electric arc furnace. These are the two ways of melting, and then this metal get transferred into the ladles. But nowadays we don't see electric arc furnace much. So like induction arc furnace to pouring ladders or transfer ladders. This is the very popular route now. When it is iron foundry, again induction furnace. Sometimes people are also there. From that, we can take metal into the holding furnaces, or maybe into the ladles. I'm just okay. So, and no, this is holding furnace, and from this could be one way, like induction furnace to holding furnace to ladle, or cupola to holding furnace to ladle, something. Cupola also nowadays we see means we don't see it much. So like normally it is induction furnace to press pour, or unheated tundish, or say directly ladles. So this is just a small video about induction furnace. If proper care is not taken, then what can go wrong with induction furnace. I'm sorry about the quality of video, but still hope it is visible.
Sir, it's visible, but I don't know if the video is playing.
Yeah, it is playing. Yeah. So,
yeah.
Yeah, so I'm sure melting engine, or the person who are in melting would they can relate it easily. This is like because of the metal penetration, this coil get punctured, and it resulted in furnace blast. So that's why when it comes to refractory, foundries are always very concerned. Like they readily, hardly they accept the change in the refractory sources, the materials. They means since a lot of safety is involved, nobody want to play around it. So that's why uh, we know this now, what are the consequences and all, and accordingly we take care. Means no, when it is means product offering services, so we have always in mind that how safety is important, and how should we treat any refractory trials. So with this, like same way, like what we have seen in the last video, because of the like metal get penetrated, and the most of the time metal get penetrated from top side, and the reason is it is ignored area normally, because whatever lining means we choose lining very carefully for this main furnace lining. But when it comes to spout top area, then we just use like anything, the same lining material which is used for furnace, or used lining material. We can use silica sand, some castable, but all these products are not designed for those applications for spout and top lining. Why? Because these area, the spout and top, they are they are exposed to severe conditions like heavy abrasion, thermal shocks, slag attacks, and that's why there is always tendency to form cracks, then inclusions, and through these cracks metal penetration, chances of metal penetration very high. And as a result, it like very costly runouts, and safety is also getting compromised. So that is the risk associated with it. And so what is the product? So blue ram HS, which is specifically designed for that application, for spout as well as capping area. So it is a plastic material, plastic refractory, ready to use material. It will come in the form of cakes. We can see the installation in next slide. It is a installation video, how we can install the blue ram HS on furnace, spout and top area. So you can see these are ready to use material, cakes. It will come in a cake form. You can just cut it and just apply it. So this pneumatic rammer is used. The we can use hand, I mean, like hammer or hand rammer, something like that. But the we need ramming, means we need to apply some force to fix this refractory. Whatever excess material is there, we can remove it. We can store it in like in covered condition, and it can be used later. It is not wastage. So it is mica sheet, slip plane. Okay, so about installation of blue ram for spout and this capping area, these are some guidelines. So blue ram basically it is ready to use material and can be applied by ramming application. Like before before we use it on that platform like spout, we need to ensure it is clean. If it is earlier refractory is there, we need to remove that, and then only we can apply. So like application video we have seen, through ramming only we have to apply. About this capping application, this needs to be done not immediately after lining, but when this top surface, top area becomes hard, fully sintered, and when it has to get repaired, then the repair should be done with the help of blue ram, like this. So after repair, after installing, just ensure venting is done so that gases can escape and no cracks will be formed in the material. So blue ram basically is giving excellent refractoriness, holds like higher temperatures, very durable material, mainly designed for that application, so that it can absorb the shocks, it can take care slag attack, and that's why and it is having non-wetting characteristics, so less slag sticking tendency. So overall, yeah, the metal discharge is clean. So these are some benefits. Now, same way when it comes to like furnace lining, like that is also very important area. We are talking about steel foundry induction furnace lining. So here there is a risk of erosion in refractory. Then like uneven erosion, which can also lead to the metal penetration. And some here you can see here the erosion is less, and here it is more, some cracking tendency. So that's why good choice, consistent quality neutral ramming mass is very important, and that is how we offer our neutral ramming mass, which is Kelundat 857. This comes in 25 kg bags, and maybe one video on this. So again, they have started with the blue ram on spout. Means we always recommend, uh, means during lining installation, first lining or first installation should be on spout, and the material should be blue ram HS, and then we can do this furnace lining, main body lining. For that, before lining, just as a protection for coil, these mica sheet papers are used. So during furnace body installation, 2 points are very important, like compaction and de-airing of the material. So that's why like vibrators are also used. If not vibrator, if we have to do lining manually, then ensure proper compaction is done, and at the same time like de-airing by using that forking tools. Uh, de-airing is done. So, during installation, these are two important points. And then after that, Sintering is another important step. So just what we have seen, like before installation, spout needs to be made with the blue ram. Then my use of mica sheets. Then we have to prepare bottom with the help of vibrator. If it is not there, then ensure manually it is getting compacted very nicely. And after putting former, we have to fill the lining. The sintering cycle needs to be followed. So that means here we need to ensure that the former uh, should not melt before metal reaches to the top. If it melts earlier, then like that will be fast sintering and may result in like early erosion of the lining. So same thing what we have discussed. This is mentioned here. So as far as sintering is concerned, like solid sintering and liquid sintering are the two types. Both sintering, this calundite is compatible for any means either solid or liquid sintering. So based on furnace capacity and lining thickness, we we give the sintering procedure. So typically like 50 to 60% of furnace capacity is the requirement of refractory, uh, like furnace lining material. So this is something like we need to understand. Like when lining is new, you can see like a small sintered layer of material, then semi-sintered, and major like is in the powder form. So basically to take care of metal penetration, if it comes, then this powder lining will take care of that. So when the lining becomes old, then the powder form becomes like smaller. But if your furnace lining condition is good, like the measure for that is when you break the lining, there should be like a situation like this. You must have material in powder form at the backup, then semi-sinter form, and then sinter form, which is metal facing area. So obviously metal erosion is more, yeah, lining erosion is more when it lining becomes old. But this powder form should always be there. Like during usage, there is always a tendency of some crack formation because of the thermal contraction expansion behavior of the lining material. So how to take care of these cracks? That is what we tried to show you in this picture. So do not fill the cracks like this. We just need to apply the patching material just to cover the crack. Because when again we start the furnace, uh, when the material gets heated up, then automatically these cracks are getting closed because of the thermal expansion property of the material. So if we fill the crack, then during contraction on receipt of energy, then this will exert pressure on linings, and some more cracks will get generated. So we need to take care of this. We should not fill the crack. And the material like VSA 120 HP is we recommend for patching application. So now for ladders. So we have seen furnace spout capping installation practice where blue ram HS can be used, and it can be used for like steel melting furnace or iron melting furnace. But when it comes to kelundite, we have seen the second application, which is furnace lining, and that is for only steel, and material is kelundite. Now for third area, which is transfer ladders or pouring ladders, for both iron as well as steel foundries, we can use a different range of products like Criterion, Duraflow, Circus. Like in the beginning, we have discussed now based on the cement content, there are different types of refractory. So, for example, Circus is conventional castable refractory where cementing agent calcium oxide is more. Then this Criterion is low cement castable. Duraflow is again ultra low cement castable with it is self-flowing material, and no cement castable I have not mentioned here, but that product is also there. About consumption, 50 to 60% will be the requirement means of ladle capacity. Um, like here there are it is T-spout or integrated T-spout ladle. There also we can use regular lip pouring ladders, or if it is even uh, bottom pouring ladders, there also we can use uh, any of these refractory. Again, selection is based on what performance we are expecting, what are the sizes of the ladders, temperature requirement, and cost. Based on that, we can select which type of lining material we should use. A small video about uh, how this ladle lining can be done. The material used here is low cement castable, so it needs former, and vibrator also we need to use for good like homogeneous installation. Mixer used here is a planetary mixer so that it ensures proper mixing of the material. We can adopt some of these practices about safety. So proper guarding is there, and ensuring proper mixing is there. So again, like normally we ignore the water addition. Like we, as per our judgment, we normally add, but that should not be done. Like based on the type of refractory, we should calculate the water amount. Maybe not exactly, but in the range. Like if it is required 8%, then we can consider some 7 to 10% or 8 to 10%, and so, but it should be calculated, because very for like if water addition is more, then when we preheat the ladle, majority like this water gets evaporates, and the lining material left with more porosity. So and if porosity is more, then it will result in more slag generation, more slag deposition, because that porosity will act as a notches where slag can deposit very easily. Overall refractoriness of the material will get down, and overall our performance of refractory will be down. That's why we need to take care of these small things. So overall about lining materials, uh, no, this is uh, like a broad view. What are the different, like when it comes to induction furnace lining for steel, it is kelondite. Then these are the materials which are readily available. Apart from these, there are various other materials also, where the manufacturing center is Vizag, where we can make customized grades also. But these are some grades which are uh, available, and which are like proven products for foundry applications, and we can easily like go with these materials. So like low cement castable range, then conventional ultra low cement for patching. We have seen this. Then for coil coating, we have material which is having very high alumina and again very good product. Mica sheet again a safety from safety point of view. Then something for aluminium we will not discussing here, and Libram HS, which is actually it is the only material which is not made in India, but from availability point of view, we can assure you that material will be always available. So now these flow control systems will discuss something on this. How flow control means flow controls are basically for as far as foundry is concerned, it is a combination of two products like stopper and nozzle. So together it is acting as a wall. Whether it is a bottom pour ladle for steel or say auto pour, press pour, unheated tundish in case of iron. It is basically acting as a wall which controls the metal flow. So and there are different, as far as steel foundries are concerned, there are different types of stoppers and nozzles. Like stopper rotolog is Foseco's patented product. You can see this. It is a stopper head, and inside that there is an insert. So in insert the rod will go, and then the refractory sleeves will be there to make the entire stopper. So that is a rotolog, or in foundries it is called as like assembled stopper. So stopper head and refractory sleeves combination. And other type is Viso stopper, Viso monoblock stopper. This is, you can see in the drawings, in the pictures. So it is carbon bonded material, like alumina base, high alumina base, and we having very high refractory ness, so that it can withstand that high temperature of steels. So this is the thing, and these are the various types of nozzles. Like this is regular nozzle, and this is something different, which is called as crossbore nozzle. So we can see, but before that we can see this Viso stopper installation video. Yes, so that was the steel pouring ladle bottom pour mechanism, and we have seen the stopper installation, how it does. Some of the actual on shop floor pictures we have tried to share here. This after installation, Second step is this: we need to put a stopper under preheater. In the ladle stopper is there, and it needs to be preheated. So at hot degree, so around 900 degrees Celsius, we need to preheat. It should be red hot before before metal gets tapped. So after this, after pouring completes, then this is how it looks. And like after use, we have to miss if the next hit is immediately, we can use as it is, and otherwise we can take it out, and we have to store it on a vertical stand. There you can do some repair works also. If nose we call it nose of the stopper. If nose is having some slight deposition, there you can clean it. And again, we have to practice the same. We have to follow the same practice which I've seen in the video. Like we have to install it, then we have to ensure that no, there is no leakage. Like they put sand, and sand should not get away from the nozzle. So and then before metal taking, we should preheat it. Now about crossbore nozzle. Uh, so a different type of nozzle. So this is a regular nozzle where you can see the metal flow here, and this is crossbore nozzle metal flow. The difference is very clear. Like there is more turbulence in regular nozzles, and you can see a very laminar flow. And the benefits, obviously, like oxidation will be less, metal wastage, like it will feel very accurately, and because of the less turbulence, other from casting quality point of view, like surface finish and all, that will also be good comparatively. So that is about crossbore nozzle. uh, the stopper, which is used for iron foundries, basically in unknitted tun dish or press pores. So there we have different stopper technology, which is VAPEX. So for steel, we recommend VISO stopper, and for iron foundries, it is VAPEX stopper. So technologically, there is a differences, and the major difference in terms of oxidation resistance. Like for in case of ions, we need more oxidation resistance, and that's why these are the specially designed materials for considering those applications. Then this is another improvement or technology which Foseco have, a new product which is VAPEX fast flow nozzle. So it is basically a nozzle system which can be used for steel as well as iron foundries. So how it works, again a small animation video about this working. basically there are two nozzles in Vapex cross flow nozzle system. There are two nozzles. One is base nozzle and other one is pouring nozzle. So the pouring nozzle, we can change it when ladle is in red hot condition. When stopper is also there, stopper is installed, and it like just after one pouring, if you want to use different dia nozzle, so immediately in hot condition you can use without any delay. So your production will not affect. So these are some benefits, and same we can use it for your press force or unheated tundish, like no, to minimize the downtime means uh, uh, when it is like press pour, you can change the nozzle immediately in running production as well. So this is something Foseco's new process, a patented technology. That's why. So at the end, like, why Foseco? Why should means we use Foseco's products? So it is a global technology and available locally. Like we have local manufacturing centers. Like in Vizag, we have R&D setup. Very good manufacturing facility. Monolithic production capacity is around 5,500 tons per month. So like we have seen fast flow cross-bore nozzles. So these are some innovative solutions we like always offers. And overall consistent quality products with support from global expertise, global supply chain. So with these means uh, some development in foundries will always be there with the help of Foseco team. So that is it. So now we are at end of the presentation. So, so anything if you require, we can connect separately. We can contact myself or Dhananjay. You can visit our website for more details, more product to understand more products. So with this, I thank you very much for attending and for giving your time. So any questions, we can discuss it now. Thank you very much.
Thank you, Mr. Vivek. So thanks for the presentation. So gentlemen, we are now open for question and answers. So requesting participants to ask any questions, if any.
I'm Jairaj. Can I put a question?
Yes, sir.
I'm Jairaj. I retired as a general manager from Steel Authority of India Limited, where refractories are consumed in large quantities. Of course, I was not on the production line, but on the marketing plus other, lines not related to marketing. My question is, how much of our refractory requirements in the country is, from the indigenous production, and why we are importing? And then what is the quality of the indigenous production? Because refractory forms a very important part of any steel plant or any foundry. I would be happy if you can enlighten me and the others also on this. What is the future of the refractory industry, whatever it is?
I will try to attempt this question. Basically, means as far as VSOS is concerned, our 70% raw material are imported, and only 30% are indigenous. So, but the like futuristic approach and all means I'm sure there are like many companies, many manufacturers which are setting up their plant in India. And with this approach, I believe that indigenous raw material consumption or the requirement should go up. So exact details I cannot means I'm not aware at least. So maybe my friend Dhananjay can help manager can tell us.
Hello.
Yes.
Dhananjay.
Tell
Uh,
me.
Please.
Actually, the refractory, as Vivek earlier told that we are importing almost 70% materials, importing materials. Most of the foundries are now, most of the whatever the multinational players also are coming and setting their plants in India, as India is a growing industry and foundry business is going on. But still, some of the products we are depending upon imports only. Some sources are not that much quality of products are available in India.
Hmm.
So alternates for that, the research teams are thinking on that, and based on that, they are trying to develop suitable products.
Yes, yes. Sir, basically, countries, we are an emerging economy, so foundries and metallurgical industries are a must, for the growth of the country or development of the country. So there is a lot of room for, and refractories again forms a very important part of foundries and the metallurgical industries. So which means there is a lot of room for development of the refractory industry within our country. Am I right? That means accordingly, in the national interest, we should also develop the refractory industry along with, as we go forward as an industrial power. That's what makes it.
Thank you. Thank you,
Yes,
sir.
sir. Yes. And I
Do we
totally
need
agree
any-
with your point, sir. Yeah.
Okay, okay. Yeah, thank you, sir. Thank you.
Do you have any further questions, sir? I think one Mr. Ajit has raised his hand.
Good afternoon, sir. It's
Good
Sajid
afternoon, sir.
from Belgaum Big Casting.
Yes, sir.
Sir, actually, in consideration of acidic, basic, and neutral, how it will impact on casting quality, sir? Any defect generations and any slag intrusions in comparatively in three processors, which is one is the better, sir? Because some of the customers is denying to go for neutral because of the some quality issues and all. So, as per your concern, sir, which one is the better process for adoption for steel casting?
Okay. Yeah. Yeah. So, like choice of refractory material is based on the uh, the metal type and the mainly the what type of slag is getting generated. So when it is steel, then the nature of slag is basic, and if we use acidic lining material, then it will erode very fast, and means that is really not recommended. Then other choice could be naturally basic ramming mass, but there are different challenges with basic ramming mass also. Like it is not having like when we the thermal shock properties poor with the basic ramming mass. The crack generation will be more. Then overall slag deposition comparatively more. So to overcome these challenges, uh, like neutral ramming mass has come in picture. So neutral ramming mass is actually combination of both the properties. Like it is having good thermal shock property as well as better slag resistance or better erosion resistance. So for steel, we always recommend use of neutral ramming mass. Is that answer to your question, sir?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Thank you.
Thank you.
Any further questions, gentlemen?
Vivek sir, I'm Venkappa here.
Yes, sir. Yes,
Yes,
Bhargava,
sir.
sir.
Yes,
Please.
sir.
Sir, one item that blue wrong HS, you are giving some technical information.
Yes, sir.
So in that mouthpiece, we cannot build that material on the same day. We have to wait for a day or two, no?
Right, sir. Like the reason is initially the lining material is not fully sintered,
It
so it
will
is
not be
not.
in crystallite. It will be in the quartz form only.
So that's why means top area needs to be means initially you have to use the same material which you are using for main body lining.
Okay.
Okay, then over a period of time, maybe after 1 day or after 2 days, because of the impact of charge mix and other severe conditions, that top area is like tend to erode or tend to get damaged. So there, that time you need to repair it. So that repair should be done with the blue ram HS.
Sir, if I'm not wrong, I think sir is asking about spout, not top.
Correct. What he's telling is, Vignesh, what he's giving answer is right actually. See, what is my question is, yes, what he said is right. Same day, because the quartz has to be get converted into crystallite, then it will form the original strength. Then only we can put this mass on the spout. So how do we manage till putting your blue ram was my question. As he rightly said, we can have same ramming material over there. Next 2 days we can remove that material, put this blue ram HS for a better life. See, instead of doing every day, normally we use sadomati or something like that, so which will not be productive. Every day we have to change the spout. So by using his product, blue ram on HS, I think once if you do it, it will be like lining only. Once again, correct, sir?
Yeah, minimum.
Minimum. Okay. Thank you, sir.
And as far as spout means, I think I misunderstood your question. Means for spout is concerned, we can do it from like initially itself. Before you line the furnace, you should always start with spout lining. As we have seen in the video, spout should be made with blue ram HS. Then yeah, it is plastic in nature, so it will be having some workability. So you can torch it with the help of burner and make it hard. It will take like setting time is around like 2-3 hours. It will get hard if you use the burners to preheat it, and then you start furnace lining, furnace lining, and then sintering. Yes.
Okay. Thank you, sir.
Thank you.
Any further questions?
Of course, my view is it has been a very good presentation, quite informative and helpful, particularly those in the foundry industry and those who are interested in the foundry in the future. That's what my feeling is. Good.
Thank you.
Thank you, sir. Any further questions, gentlemen? Otherwise, we can go ahead with the vote of thanks. Right. In that sense, I think we can go ahead with the vote of thanks. We now request our Honorary Secretary, Mr. DG Benakappa sir, to propose the vote of thanks.
Thank you, Vignesh. So hi everybody. So it was a nice training program on advanced refractories and flow control system. So it was very informative. See, the technology is upgrading, so we have to upgrade ourselves for the better results and economy. See, let us try to understand the best going around the world. Definitely, it will bring fetch lot of good results to the foundrymen. Thank you, Mr. Vivk Pol, Solution Manager. You have given a very fantastic presentation. Even you have shown one video where accident case was there. It was very informative. See, such things are required. See, it becomes an educative video like. Thank you, Mr. Vivk Pol, for a wonderful presentation with a lot of technical inputs. Thank you very much. And thanks to our Chairman Muthukumar sir and Saktivel sir and Vigneshan for organizing a beautiful technical program. Thank you, sir. Thanks members from SR and all the chapter people to involve into this technical presentation and asking very valuable questions. So for clarification. So thank you. Vignesh sir, nice to see good technical programs being organized by Chennai chapter.
Yes, sir.
Keep rocking. Hope other chapter also will follow your guidelines. Congratulations. Thank you one and all, sir. Thank you.